Hello, we are starting another chapter, chapter 14, which is all about aldehydes and ketones. So remember, aldehydes have the following structure where there is a hydrogen bonded to a carbon that has a double bond to oxygen, and then ketones have two other alkyl groups bonded, and they can be the same or different. Now down below you can see some test tubes with different colors in them. Those are specific tests we can use to figure out if we have an aldehyde or a ketone, but we'll talk about that later. Now, we have been referring to carbon double bonded to oxygen as just that, but there is actually a name for this specific bond, and we call it a carbonyl group. So if you see a carbon double bonded to oxygen, you can just say that you have a carbonyl group. So aldehydes have at least one hydrogen attached to that carbonyl group, and ketones have two carbon groups attached to the carbonyl group, one on either side. And again, those could be the same or different. And here I'll just highlight our carbonyl group here. So some examples of aldehydes and ketones are formaldehyde and acetone. So formaldehyde here on the left is a preservative, and you'll notice that it does have that carbonyl group, so the carbon double bonded to oxygen, and there's actually a hydrogen on both sides of the carbon. The other example here is acetone, which is found in nail polish remover. It's also a really good solvent for most molecules. So it can dissolve a lot of different types of molecules. And you'll notice that, again, we've got that carbonyl group, and we have a methyl group on each side. So you can probably guess which one is the aldehyde and which one is the ketone, even just based on the name. Formaldehyde has aldehyde in the name. Acetone ends in O-N-E, so the same ending as ketone. Okay, so let's talk about how to name aldehydes first, and then we'll talk about how to name ketones. So it's pretty simple. We're going to, again, find the longest carbon chain that contains the aldehyde group. Then we're going to change the ending of the hydrocarbon name. So for instance, if we had one carbon, maybe we call it, methane, but then we're going to drop the E and add AL on the end. Now, all other branches and groups are named and located using that standard IUPAC system that we've talked about before. So you'll just treat all of the other groups as we normally would. You're going to name the group as, methyl, ethyl, propyl, etc. And then you're going to list a number to give it a location on the chain. So let's look down below. On the left-hand side, we have an example of an aldehyde. So there's our functional group. So what we're going to do, since the aldehyde group kind of has to be on the end of the molecule due to that hydrogen, that will always be at position 1. And then we'll number our other carbons in our longest carbon chain. So it looks like we have 4 carbons in this chain. So if this were an alkane, we would call that butane. But because we have that aldehyde group, we're going to drop that E and it's going to become butanal. Now we also do have a bromine group attached to carbon 3, so we'll just call that 3-bromobutanal. All right, let's look at our other example on the right. This is also an aldehyde. So we've got our aldehyde group here. So we need to find the longest carbon chain, and this can make it a little confusing since it's in the middle there. This looks like a pretty symmetrical chain of carbons here, so we want to again start with our aldehyde carbon, and then we'll go down. Okay, so that's 2, and then 3 and 4. So it looks like we've got 1, 2, 3, 4 carbons again in our longest chain, so that's butanal. And then we've got this 2 carbon chain that's just kind of hanging out, so that will be a group that's attached to our longest carbon chain. So this is on carbon 2, so this is 2-ethyl butanal. All right, so let's do some practice problems. So I'm going to give you some aldehydes, and then I want you to try to name them. Okay, and then I'm going to give you another one here. All right, see if you can name these aldehydes on your own first by pausing the video. And when you're done, you can unpause and we'll go over them together. All right, so let's start with the one on the top. So I can see our aldehyde group here on the end. And again, that's going to be carbon 1. So we're just going to number this going from right to left. Okay, so there are 6 carbons in that longest chain. So normally we would call that hexane, but because there is that aldehyde group on the end, we're going to drop the E and add Al. So this is hexanal. Then we also have a methyl group here on carbon 3. So that would be 3-methyl. So overall, the name is 3-methylhexanal. Now down below, I can also see we've got our aldehyde group on the end of the molecule. So that is carbon 1. And we're just going to go down the chain. Okay, so we've got 5 carbons. So normally that would be pentane, but because this is an aldehyde, it's pentanal. Now here we have 2 groups attached. We have a bromine on carbon 3 and a chlorine on carbon 4. Okay, but remember we also want to alphabetize. So would bromine or chlorine come first? Bromine, it starts with B. So this is going to be 3-bromo, 4-chloro, pentanal. Okay, so not too bad, right? Now there are some common names for aldehydes as well. So earlier we saw the example of formaldehyde. But we could also call this methanal because there's only 1 carbon in that molecule. If you have 2 carbons in your aldehyde, the official IUPAC name is ethanal because, again, there's 2 carbons. But the more common name for this molecule is acetaldehyde. And this is actually a molecule that forms when you're breaking down ethanol in your body. If you have 3 carbons in your aldehyde chain, we could call that propanal, but the more common name is propionaldehyde. I personally prefer propanal, it's easier to say. Now, if you have 4 carbons in your chain, you can call that butanal, but there's also a common name, butyraldehyde. And then if you have a benzene ring attached to your aldehyde group, we just call this benzaldehyde, no matter if you're using the IUPAC name or the common name. So I'll try to make some flashcards for these just so you can keep track of these different naming schemes for all of these different aldehydes. Now, one other thing to notice on the side here is we have the boiling points listed for each of these different aldehydes, and you can see that it increases with an increasing molecular weight. So the more carbons and hydrogens you have on your molecule, the more energy you'll need to break apart those molecules from each other. So you're going to have a higher boiling point as a result. Now, how do we name ketones? So pretty similar to before, we're going to find the longest chain that contains the carbonyl group, because remember that carbonyl group in a ketone has 2 alkyl groups bonded to it. So the ketone will likely be in the middle of the molecule. Then we're going to drop the E ending for, the typical way that we would name an alkane, and we're going to change that to ONE for ketone. Then we want to number the chain so that the carbonyl group has the lowest number possible, and we'll just name and number other groups that are attached as before. So we have an example on the left down below. So we want to again identify the longest chain that contains our carbonyl group here. So it looks like that would be this one here, pretty easy to figure out for this example. And then we have to decide, do we number from right to left or left to right? So we do have 2 functional groups, or 2 groups, I guess, here. We've got our ketone group, the carbonyl group, and then we have this methyl group down below. Now we're going to prioritize the carbonyl group because it's in our longest chain. So we want to number from left to right so that the carbonyl group has the lowest number possible. And then the methyl group will be on carbon 3. So we end up with the name 3-methyl-2-pentanone. So ONE is our ending there. Let's look at our example on the right. So in this case, we have a ring system. So the ring will be our parent chain, or our longest carbon chain. And again, we want to prioritize the carbonyl group, so that will be at position 1. So normally we would call that ring cyclohexane, but because we have a ketone attached to one of the carbons, it becomes cyclohexanone, so ONE. And then the methyl group, we want to give the next lowest number possible, so it's on carbon 2 here, so this would be 2-methyl-cyclohexanone. Okay, so let's practice. So I'm going to give you a few examples here. And then I want you to pause the video and try to name these on your own first. And then when you're done, we will go over them together. All right, let's start with the first one on the top. So again, we want to find the longest carbon chain. So on this molecule, that's pretty easy to find. It's just straight across. And again, that longest carbon chain should also contain that carbonyl group. And then we want to number the chain so that the carbonyl group has the lowest number possible. So would we number it from right to left or left to right? Right to left. All right, so the carbonyl group is at position 3. Now overall we have 6 carbons, so if this was an alkane we would call that hexane, but because we have a ketone in the chain, this becomes hexanone, O-N-E. And then we want to make sure to indicate where the ketone exists or where the carbonyl group exists. So it's at position 3, so this is called 3-hexanone. Okay, let's go to the next one. We have a ring system here, so similar to what we saw on the last slide. So what would we call that ring since it has a ketone in it? Cyclohexanone. And then we have a chlorine that's directly across from the ketone. So we're going to number this as 1, 2, 3, 4. So that is 4-chlorocyclohexanone. Now for the last example, we need to find the longest carbon chain that contains the carbonyl group. So we have to make sure to include this carbon here. So that means we're also just automatically including the methyl group to the right and the carbon down below. Okay, so now we have to decide what is the longest chain. Do we go to the left or to the right? To the right because there's more carbons on that side. Okay, so now let's number this so that the carbonyl group has the lowest number possible. So I'm going to start numbering at the methyl group so that the carbonyl group is at position 2. And then we'll just keep going. Okay, so again, we have 6 carbons in our chain. So this will also be hexanone. And we know that the carbonyl group is at position 2. But we also have this 2-carbon chain that's attached. So what would we call that? 3-ethyl. So the full name is 3-ethyl-2-hexanone. So sometimes these can get a little confusing if they're written out this way because the ketone looks like it's a group that's attached to the main chain, but actually it's part of the main chain. So you want to make sure to find that longest chain that does contain the carbonyl group. All right, now there are some different names for certain ketones. So for example, if you have 3 carbons in your chain, you might call that propanone if you're using the IUPAC name system, but this is also known as acetone. And it's probably more commonly called acetone. Now there's also a 4-carbon chain ketone, which we could call butanone using the IUPAC system, but the common name is methyl ethyl ketone. So that's kind of similar to how we would name ethers, right? You've got a methyl group on one side, an ethyl group on the other, and then your ketone. And then finally we have cyclohexanone, which is the same using either method. Now also notice that the boiling point increases with increasing molecular weight, similar to what we've seen before with alkanes, alkenes, aldehydes, alcohols, etc. So just something to keep in mind for physical properties. And speaking of, in the next video, we're going to start going over physical properties of aldehydes and ketones. So we'll talk a little bit more about boiling points, intermolecular forces and all of that good stuff. So I will see you then.